Before we start, let me mention for those of you who don't know that I have this FM prep book, which I keep updating whenever SOA makes a change in its syllabus or adds more problems or renumbers its problems. And this book contains the solutions to all the current 462 SOA sample questions, plus a lot more questions. As you can see from here, it has a total of 620 problems. The additional problems are in the form of quizzes and practice exams, and they're all SOA level questions. And the first 125 or so lessons that you see on YouTube are exactly the same lessons in this book. And the YouTube videos are in synchronization with the lessons of the book, although the book has additional quizzes, which you don't see in the videos. And also, the book goes all the way up to more than 500 lessons, whereas the videos is only up to 125 or so lessons. And so, if you want the complete course, the book would be the way to go. I'll be making videos gradually, but it may take a while before all the lessons are on the videos, and still, even in that case, the quizzes won't be there. And I highly recommend that you always buy the new book because I mentioned in the beginning that I keep updating whenever SOA makes a change. It's possible that you may find some used versions in the market, and they may be the older versions and not updated as this one is. And so to get the new book, you just get it from the Amazon, the new book that is sold by Amazon itself and not by any third-party sellers. Okay, so with that out of the way, let's come to today's lesson. You're given the following information about a loan that is to be repaid with a series of 16 annual payments. First payment of 1,000 is due 1 year from now. Next 7 payments are each 3% larger than preceding. And from 9th to 16th, each payment will be 3% less than the preceding. The loan has annual effective 7%. Calculate the loan. So we see the first payment of 2,000 is at time 1. Second payment is 3% larger. So that's 2,000 times 1.03 at time 2. Third payment would 3% larger than the previous one. So 2,000, 1.03 square at time 3, and so on. So eighth payment of 2,000 would be 1.03 power 7 times the 2000 at time 8, because you see the trend here after, for example, if you look at the third payment, the payment number is 3, but the power of 1.03 is 2, which is 1 less than 3. So that gives us the pattern that for the eighth payment, the power would be 1 less than 8, which is 7. And the ninth payment would be the eighth payment times 0.97, because starting from the ninth payment, you have a 3% reduction. So up to the first 8 payments, there was a 3% increase. But starting from the ninth payment, there's a 3% reduction from the previous payment. So a 3% reduction of the previous payment means that the previous payment is 97% of the current payment is 97% of the previous payment. So that's why we have the eighth payment times 0.97 to get the ninth payment, and that's happening at time 9. Similarly, the 10th payment would be the ninth payment times another 0.97. So we pick up 0.97 power 2. In the 11th payment, pick up 0.97 power 3. And in the 16th payment, we'll pick up a 0.97 power 8 if you keep going like that, one by one. So now we see that the first 8 payments are a geometric annuity immediate, with the first payment of 2,000, growth rate of 3%. And so the present value of the first 8 payments would be x times 1 minus 1 plus k over 1 plus I power n over I minus k, according to the formula in lesson 123. So that's 2000 times 1 plus k is the growth rate, so 0.03, 3% growth rate. Interest rate is given to be 7%, so 0.07, and then divided by I minus k, 0.07 minus 0.03. So this gives us the present value of the first 8 payments to be 13136.41. And now payments 9 through 16 are also geometric annuity immediate because there's a constant ratio between consecutive terms. But now the growth rate over here is negative 3% because it decreases by 3%. And the first payment in the formula for the present value of geometric annuity in this case would be this 2000 times 1.03 power 7 times 0.97. So you see the x over here represents the first payment of the series. So for the payment of the series 9 through 16, the first payment is this one, 2000 times 1.03 to the 7 times 0.97. So that's why this serves as the x for the payments that go from 9 to 16. And so x times again 1 minus 1 plus k, and the k, as we said, is negative 0.03 now because these decrease by 3%, over 1 plus I is still 0.07, I minus k, 0.07 minus negative 0.03, so that gives us 12976.12. And this is the value of the payments 9 through 16 at time 8. And the reason for that is that we are applying the annuity immediate formula, geometric annuity immediate formula, this one. And we know that in the annuity immediate, the present value present value formula that we apply gives us the value one payment, one period before the first payment. So the first payment in this case is this ninth payment, which is happening at time 9, and one period before that means we go to time 8. So that's why the present value formula in this case gives us the value at time 8. And then if we want that value at time 0, which is the present value of these payments 9 to 16, so we bring it back from time 8 to time 0 by multiplying this value by 1.07 to the negative 8. So we get 7552.22. So we have the present value of both the streams, the first 8 and the 9 through 16. And the overall present value would be the sum of those two. So we sum the 1 and the 2, and that gives us the overall loan, which is 20,689. That is choice A.